In this video I'll try to show you the solution, or we'll go through the solution of question number 2 in your class 1 ECN225. Okay, let's read this question. Let the model be yi, okay, and its OLS estimated version be yi beta 0 plus, okay, prove that. Okay, we need to prove that sum of the residuals, so I runs from 1, this is I 1 to n, so sum of i hats is equal to 0. So that's what we need to prove. So, and as you know, this u hat i's are errors. Now what is it equal to? U hat i's are basically equal to yi minus y hat i's. So this is the actual y, this is the predicted y. And if you do this, if you plug in the formula for predicted yi, you will have beta 0 hat minus beta 1 hat xi. And then if you plug in further the formula for beta 0 hat, so estimator, then you get this value. And I showed you in the last video how to get the work out the solve equations for beta 0 hat, or to work out the estimator for beta 0 hat, beta 0, sorry. So this would be then, if I just plug in the, well, that formula, I'll just quickly show you what it was in a different color. The formula for beta 0 hat was, if you remember from the video we did, so this is y hat minus beta 1 hat, sorry, y bar I should say, x hat. Yeah, I'll just plug this expression into here. Right, so let's get rid of that now. And let's change the color to normal color. So this would be y bar minus beta 1 hat and x bar minus this value here, beta 1 hat xi. Now we can do further simplification. Well, actually it's time to, so I'll just put a big dot here. It's time to put this into this expression, this final solution here. We'll put it into here and then see what happens. So, oops, I shouldn't do that. Let me go back. So that is sum of ui hats equal then, so I again 1 to n equals sum. Now I plug this expression that I just derived here into this ui hat formula. This will be bar plus beta 1 hat x bar minus beta 1 hat xi equals, well it's equal to 0, but I'll just carry on solving for it. Now let's do a very quick trick here using algebra. I could factor out beta 1 here, so, and then rewrite this equation, yi minus y bar minus beta 1 hat, and then just swap the places between this xi and x bar. So this will be xi minus x bar. Let's put a square bracket and equal, so follows. Now let's use the first rule of distributive, well, it's not first rule, it's a distributive rule of summation operator. This is runs from n. Then you will have yi minus y bar minus beta 1 hat y, sorry, this is now xi minus x bar. And this is beta 1 hat is actually constant, so I put it outside the summation operator. So this is 1 to n again, 1 to n. And from the previous video about summation operator, if you remember, I showed you and proved it as well that deviation of sum of deviation is 0, and sum of deviations here again 0, so you will have a 0. So yeah, you just proved it, that sum of u hats are 0, well, sum of errors are 0. Right, so next, the second equation to prove here, a bit lengthy to do. In that case, let's do this. I need this expression for that exercise, but I think I have a note of it, so I'll just clean this now, clean the space and restart it. So we have to prove that ui hat xi equals 0. That's the requirement. And from the previous exercise we know that the ui hat is equal to something here, so I'll just plug that in. So ui hat is equal to yi minus y bar plus beta 1 hat x bar minus beta 1 xi hat. Right, so I'll just plug this into here. Then what you will have is yi minus yi minus y bar plus beta 1 hat x bar minus beta 1 hat xi times xi equals, so that's this separation, this expression here just becoming a bit lengthy because of plugging in ui hat here. Now let's carry on doing this. What do we do next? Let's multiply xi into and then see what we have. It's a bit lengthy proof, but will be interesting. So if I multiply xi by yi by xi or otherwise, and then this would be xi here plus beta 1 hat x bar xi minus beta 1 hat xi times xi equals. Now let's do a few simplifications, and we'll be using distributive rule of summation operator again. So in that case, each of the terms will have their own summation operator because all of them have I index, right? So minus, now this here is summation operator y bar times xi. Y bar is a constant, is an average of y's, so will be outside. We'll put it outside summation operator to make it simple for ourselves later. So plus here again beta 1 hat and x bar together are constants, so will be out, but the other one is indexed by I, so minus here again this beta 1 hat will be out. Inside this operator is the square now, because these together this will make square. Next, what can we do further to simplify it? Well, let's do a little bit of trick here so that we convert. We'll have only means like y bar and x bars here, and then the same here, so that we can manipulate the formula further. Right, so let's rewrite this again, xi minus, so y bar. Now here, to convert this sum of xi's to substitute this sum of xi's with some x bar and something else, so that this formula will become simple, I will do this. I'll multiply it by 1 over n that I showed you in the class. This is usual thing, times and oops, this is wrong, times it by n itself. So you will see that I don't lose anything here, because if I cancel this, then I'll have exactly the same thing here. I just multiplied by 1 over n and divide by 1 n. The same here, beta 1 hat x bar, then multiply by 1 over n xi times it by n here, so that if I cancel this, I have this expression again, minus xi squared equals. Now very quickly let me highlight something here. Now if you see this whole thing here is x bar, and the same here, this whole thing here is x bar. So let's do the next step. So yi xi minus y bar, this one here, and this will be x bar, and this is n plus, well, this is 1 hat x bar, there is x bar here, times n, minus this thing as before, xi squared equals. Now we'll rewrite this as it is. So minus this will stay as they are before, n plus, now this is a square, right? X bar square n minus, well, this is this stays as before. Now I can do this. Now I can collect the beta ones and factor it out, and let's do this very quickly here. This very tiny space, so I'll just make it tinier. Minus, I'll factor out this beta hat, and inside the bracket I will have, okay, I think I made a mistake here. If you notice, my xi squared will still be in the because this is as an I, it cannot get rid of this. We cannot drop the sigma sign there, and that's something I forgot to do earlier. So I'll just clean this. I'll correct it if in case you are copying and rewriting this. You can rewrite it now or practice it later. So that shouldn't have been left out, and here one more shouldn't have been left out. So this would be xi now squared minus this thing there, so this would be x bar squared n, right? So equal. Now we'll rewrite this as before. Final step, hopefully, if I didn't make any mistake. Minus beta, oh sorry, so I think that's something that I need to do here now. So beta 1, this, now I'm writing this part here, this beta 1 there was something you derived in the class. So beta 1 hat, what was equal to, if you remember, beta 1 hat estimator for beta 1 was equal to xi yi minus n y bar x bar. So this is capital N, and here you had sum of xi squared minus x bar squared n. Yeah, this is the exact formula that you derived before in the class. So I'll just plug that in. Okay, let me change the color now. Let's plug that in here into this expression. This will be xi yi minus n y bar x bar minus x squared. So this is a bar, this is n, times this bracket inside. Right, so what do we have now? This basically is exactly the same as this denominator, so they cancel out, and what we left with is this here minus this, which tells you that they are the same. Yeah, so basically, yeah, basically 0. So you just proved that the sum of ui hat times xi is equal to 0. This is done now. That's the solution in the question number 2. Yeah, I'll see you in the solution to question number 3, 4, and hopefully 5.